The product rule represents the derivative of a function multiplied by another function, which is equal to the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. This can be thought of as the rate of change of an area, with an old area of g of x multiplied by f of x. If we were to increase the function and then get the difference between the old function and the new function and add that on to the sides, then we would get a new area that equals f of x plus change in f of x, all multiplied by g of x plus change in g of x. This can be separated into 4 different areas. The first one equaling f of x times g of x plus f of x times change in g of x plus g of x times by change in f of x. We also have the change in f of x multiplied by the change in g of x, but the difference may be so small that we can ignore it, which turns the new area into an estimate. This is because the diagram has exaggerated how much the change in the functions is. Subtracting the old area from this new one gives f of x multiplied by changing g of x plus g of x multiplied by changing f of x, which gives the change in area. Now, to find the derivative of this area, we need to take the rate of change of area equation and divide it all by change in x, and simultaneously put x to 0 to get the derivative. Two things. I did not put the x symbol and brackets in the equations area as to conserve space. So don't get confused when you see the change in f on its own. It still means a change in f of x, and the same for g. Secondly, I've shown what the change in a function is equal to. It is equal to that function of x plus change in x. Take away that function again of x. N can be any variable. And in this example, the change in x has replaced h that we saw in the last example. So dividing the change in function by change in x and setting it to 0 will give the function prime, which also just equals the derivative of that function. This next rule, I'll just show you what it equals to, as it is starting to get pretty advanced for a beginner course. This next rule is the chain rule, which represents the derivative of a function within another function, which is equal to the prime of the outer function of the inner function multiplied by the prime of the inner function, or otherwise known as dy over dx equals dy over du equals du over dx. This last rule is called the quotientant rule, which I can show using algebra. The quotientant rule represents the derivative of a function over another function. In this example, C will be the first function and B will be the second function, which equals the second function multiplied by the prime of the first function. Take away the first function multiplied by the second function's prime, which is all over the second function squared. Using the chain rule, we can imagine C of b of x equaling 1 over b of x, which means c of x equals 1 over x, and that c prime would equal negative 1 over x squared. The derivative of c of x becomes negative because we can translate the c on the bottom of the fraction to the top by giving it a negative indices of 1. And using the indices rule, we'll multiply the coefficient by negative 1, which will make it negative. Referring back to the chain rule, we can see that it equals negative 1 over b of x squared multiplied by b prime of x, which then equals negative b prime of x over bx squared, which would also equal d over dx in 1 over bx. Going back to the original equation, we can take the fraction and turn it into a multiplication of c of x multiplied by 1 over b of x, which, using the product rule, would equal c of x multiplied by negative b prime of x over b of x squared plus c prime of x multiplied by 1 over b of x, which simplifies to the original equation. One of the main uses of differentiation is for optimization of areas and volumes. In this first example, we will find the maximum area possible using a limited parameter. If the parameter is 80 meters, what is the maximum area that can be created? We see that 4x plus 2y equals 80. So we can rearrange the equation to get y, which equals 40, take away 2x. We can then substitute this value into y to get the area in terms of x, which equals 2x multiplying 40 take away 2x, which equals 80x take away 4x squared. We now differentiate this area to get 80 take away 8x, and setting this to 0 and rearranging the equation gives 8x equals 80, which simplifies to x equals 10. This means when x equals 10 meters, we will get the most area possible. We can see this from the equation on the right, with the parabola being at its peak when x equals 10, and this is also where the derivative is equal to 0, as its gradient is also 0.